today, and also how we can all participate to basically share our internet connectivity with each other. Okay. So there are a lot of different ways in which states and corporations and other authorities use and take advantage of their authority over existing internet infrastructure and also the power imbalances there to control information. And I'm only going to talk about basically one narrow way in which this happens today. But there are many different things at play here. There are like disinformation campaigns. There are like complete internet blackouts. There's disproportionate access to the internet in different areas of the world. And I mean, just in general, the global internet is something that was designed not by everybody, but by a very small group of people. And that kind of caused some of the situations that we see now. So what I'm talking about specifically here is something called internet filtering, in which a state authority and also the internet service providers in certain regions will selectively block access to different things on the internet. And this is from the UNI project's page. They release a series of reports. So this is a very cool project, which you should also look into, which is an app that you can install on your phone. And it's basically people all over the world collectively doing internet measurements and raising awareness about different kinds of internet blocking that has been happening. And so they collect this information, and it's available for anyone to look at. But they also release a series of reports. And so these are just some reports that they've released recently. And you can see that a lot of internet filtering happens at the same time as political events. So things like elections, also during protests and riots. And so in general, there's this quote that's thrown around a lot that I'm not a huge fan of. And this quote is that the internet is decentralized and it detects censorship as damage and routes around it. I don't think that's necessarily true. And it's definitely not true today, where saying something like this kind of erases how difficult it is to get around things like internet filtering and the very real impact that this has on a lot of people's lives. But the good news is that a lot of things about the internet and the protocols that we use, there's some space for subversion. And that's kind of what I'm going to be talking about today, about how we can disguise traffic and evade this censorship, and about how in places where there isn't as much internet filtering going on, we can hopefully leverage that fact and kind of share this empowerment with other people. So I have some zine-style slides now. To talk, just kind of give a very brief overview about the technical aspect of how this kind of internet filtering happens. So when we access content on the internet, specifically when we're doing this client-server model of content, we make access to specific endpoints, and these endpoints are usually very static and not changing often. And this makes it very easy for a censor to block access to them. So for example, when you access Wikipedia, you're accessing a single domain name, and it's correlated with very few IP addresses. And so it's quite easy for a censor to just filter access to that and block your traffic as it's leaving their area of influence. So we see lots of blocking of endpoints, and we also see blocking of anti-censorship tools themselves. And so there's this very back and forth relationship where we come up with ways to subvert how we are able to access content on the internet, but then the censors find out about that and they adapt their censorship mechanisms to block access to those tools. Another way in which censors block access to specifically anti-censorship or other privacy or anonymity tools is to look at the traffic patterns. And so when you use something like Tor, for example, which is an anonymity system, your traffic has very specific characteristics, and it looks different from, I guess, other web browsing traffic. And so we've seen censors be able to distinguish this traffic from other traffic and just block it, not based on endpoint, but on how the traffic looks like. So when we are coming up with ways to subvert the system, we have to keep these two basic things in mind. We want to make sure that people are making connections outside of a censored region to endpoints that a censor doesn't know about. And we also want to disguise the traffic so that it looks like something else. Again, something that a censor wouldn't care about. And these two things are very difficult when we also take into account the fact that we want as many people as possible to be able to use these systems. And so if we keep what we're doing a secret, or we keep these endpoints that people can access a secret, that makes it difficult for everybody to access them. And so what we've seen in the past with lots of different proxies we've had is that we distribute them through a variety of means, but it can still end up being the case that sensors, because of their ability to do things like reconnaissance, have been able to figure out what endpoints people are connecting to much easier than like actual people who need to make these connections. And so today I'm going to talk about a tool we've been working on recently called Snowflake. And Snowflake tries to address these two censorship problems by, first of all, instead of having more a client-server model of proxies or endpoints that people are connecting to, using a peer-to-peer model. And then second of all, to disguise the traffic to make it look like something that sensors have historically been, in some cases, a little bit less willing to block, which are like WebRTC connections. And so these could be like video or audio calls. Okay, so I'm going to give a really brief overview of how WebRTC works. And keep in mind that there's a lot of different ways to use WebRTC, so this might vary a little bit on application to application, but this is one basic usage of it. So in general, when we make peer-to-peer connections on the internet, the way this is different from a client-server connection is that the peers are basically sharing the role of client and server with each other. And so you can think of a peer as just another friend on the other end of the world with the laptop, and it's not going to be a big server machine. But the problem is that while it's easier because of things like domain names to access servers, it's a little bit difficult to find your peer. And so what you have to do first is you make a connection to something like a stun server, where you basically ask the server, hey, how can people reach me? And a server responds with your IP address and also a port, which is basically the parts, what you need to know to get traffic. It's like your internet address. And then what happens is you make a connection to some kind of signaling server, and you're going to exchange this information with another peer that has gone through the same method. So you give them an offer, and they will reply with an answer. And then after you've gone through all of these steps and made this connection to the signaling server, you can make a peer-to-peer WebRTC connection. And you are no longer connected to the signaling servers or to the stun servers. You're just connected to your peer, and traffic can go back and forth. And so the idea behind Snowflake is to use these peer-to-peer connections and to make peers who are outside an area that is practicing internet censorship to basically allow people from within a region that is censoring content to make connections through them. And so these peers are acting as proxies. And this is a really nice watercolor image that David Freefield made about how Snowflake works. So to tie it in with the previous slide, the broker here is acting in the role of the signaling server. And so this client here in this red region is basically the sensor's area of influence or area of authority. And so the client will make what's called a domain-fronted offer. I don't want to go too into the details of what this means, but it basically means that the broker is hiding behind a very large service that a sensor doesn't want to block. And also, this is very, very small traffic. And so there isn't a lot of traffic happening in this communication, which also makes it kind of difficult for a sensor to detect it and block it. And so this broker will facilitate an interaction between all of the proxies that people are running and allow somebody inside a censored region to make a connection through them, and then to the Tor network where they can access basically any internet content that they wanted to access. So in general, what we're looking for is a lot of people to run these Snowflake proxies to be these WebRTC peers for other people and to share their internet connections with them. And to do that, we've designed a web extension that you can install in your browser. And as long as the web extension is installed and enabled and your browser is running, people can make connections to you as a peer and then use you as a proxy to access the Tor network and the rest of the internet. And so how you can participate in this generally is to install a Snowflake in your browser and allow people to use your internet to circumvent censorship. If you're interested in contributing to the project, we have source code available. And all of the work that we do at Tor Project is like public and open. And so if you want to have a discussion about this or you want to contribute, you can feel free to look at our mailing list or go on to IRC. If you want to know about how to do that, you can also come up and talk to me. And you can see the source code as well. And so now I'm just going to take a little bit of time to show you what the web extension looks like and exactly what you'll see if you install it in your browser. OK, so I have it running in my browser right now. And it's just this little snowflake icon up here. It's probably a little bit small on the screen. But what you can see here is it says your Snowflake is ready to help users circumvent censorship. And then it has the number of users that your Snowflake has helped circumvent censorship in the last 24 hours. So we reset this count every 24 hours. But the idea behind this is to kind of make people aware of their existence and participating in this system. I can also show you a demo of what it would look like to have traffic go through it. And to do this, I'm just going to use a small kind of test network that I've set up. So I don't know if you can see, but the snowflake has turned green. And it says number of users currently connected 1. And so if you have this extension installed, you can see if and when people are using it. So right now, we do have this deployed. It's in an alpha version of Tor browser. And the reason it's an alpha is because there's a lot of engineering effort involved in kind of making sure that the connections are high quality and figuring out how to distribute snowflakes to people. I can also show you the number of snowflakes that we have currently connected in this network who are currently helping people who have Tor browser circumvent censorship. And so we have 401 snowflakes available, and 392 of them are these web extension proxies. So yeah, I think I will stop here and take questions or discussions. Yeah.
We have quite a bit. We have a good amount of time for a Q&A. So I wonder if there's 1 or 2 immediate questions that people have for Cecylia. I see a hand over there. And then we can also try the conversation with our neighbors again.
Cool.
How do you deal with the problem of people running the proxy being responsible for all the traffic that goes through it? So if I self-host a website at home and China traces somebody's traffic back to my house, they see my name on the website and they ban me from ever entering China because they don't like the person who's proxied through my house.
Yeah, so the question is that if you run a proxy, you're helping somebody in another place circumvent censorship, and the authorities of that place might not be very happy about this, and so you might end up getting blacklisted from that place. That is a real concern, and it's happened with some people at Tor Project who have run OBS4 bridges, particularly OBS4 bridges from an IP address that they were also using for other things. They found that IP address blocked in China specifically. So it does happen. I will mention that the other side of this, which is the users that are connecting to your browser, one good thing is that their connections from your browser go through the Tor network and not directly to whatever content they're visiting. So there is some safety there in that even though users are making a direct connection to you, so you might get blocked, your IP address might get blocked in another place, you won't see the user's traffic, and you won't be responsible for what content a user is accessing through your browser, other than the fact that it's going to the Tor network, which in some places is not great. So it's best to install the web extension if you're living in a place where you have, it's safe for you to access the Tor network in the first place. Thanks. Yep.
Hi, thank you for the talk. So my question is that, so right now you just showed that there's around 400 Snowflake proxies. Do you have any idea about the churn rates of those proxies? And say, if China really want to block it, it's like 400 IP address. So how could you distinguish if someone is an ordinary user and someone who actually working for the Great Firewall just go and ask you what is the IP address of those? So I think it's good really work if it's have a high churn rate. If that 400 proxy just stick with static IP for the next 1 week, then I don't think it's a problem for them to block it, right? So.
Yeah, that's a really good question. And so I do want to point out really quickly that we have publicly available metrics on a lot of different things. And you can go to, let me just, metrics.torproject.org. And we are collecting some metrics for Snowflake. We are not right now collecting metrics based on churn. I think we had to think a little bit about how to do that safely without storing people's IP addresses for a long period of time and things like that. I think a lot of times with anti-censorship tools, what we engineer and design ends up having a different impact, theoretically that we think than what actually happens in practice. And so as I mentioned before, how censors change what they're doing depending on what anti-censorship tools exist and are popular. This is a very real thing. It might very well be the case that censors will become extremely efficient at detecting what Snowflake IP addresses are and not worrying about collateral damage. So a lot of times when we do these things, we throw around the word collateral damage a lot, where we say, oh, censors won't be willing to block this because they'll block all IP addresses behind this NAT, or network address translation table. Sometimes this isn't true. We do see censors blocking like entire Amazon IP address space. So I think this is also one of those kind of we'll wait and see. This is a very big step forward from what we were doing before with OBS4 bridges or other pluggable transport bridges, where we had much, much fewer. And we were distributing them all through BridgeDB. So it will be interesting to find out. We are collecting measurements, and if you're interested, I can point you to the particular tickets, but it would take some searching to find it right now. Thanks. Yep.
Hi, I was wondering how easy it is to create like a malicious Snowflake proxy that's just capturing traffic or not redirecting it as it should, or things like that, and overpower the existing 400 ones.
Okay, thanks. Yeah, that's a really good question. So all of our protocols are open, which means that anybody can make a snowflake and their snowflake can misbehave. There are some additional safety measures in that when clients connect to your snowflake, they're then connecting to the Tor network. So you wouldn't necessarily be able to log things like, oh, this user's IP address is visiting these websites, which is why we have this anonymity component in there. In terms of a proxy that just drops client traffic, this can happen, but this is kind of one of those engineering problems that we're working through right now. It can also be the case that you have it running on your laptop and your laptop connection just cuts out in the middle of a client's connection to their website, and it's not any malicious doing on your part, it's just the fact that network connections aren't always super reliable. And so we're working on the ability to connect through multiple snowflakes at a time, and you can quickly find a new snowflake if your snowflake stops forwarding traffic correctly. But yeah, these are really good questions and considerations to have. Thanks.
We have time, maybe if there's one. I see a couple more hands. Yeah, for one or two more.
Cool.
Hi. Thanks very much for the presentation. It was really great. I have a question about Tor in general. I know that you only recently, about a year ago, launched something for Android, and the mobile support in general isn't always great with some of the decentralized tech. Can you talk a little bit about why mobile often comes last? Like, are there technical problems, or is it just that the dev community tends to be desktop focused often at the beginning, and maybe is that how it started, or is anything you can comment on that?
Okay, thanks. That's a really good question. A little bit off topic, and I don't work on mobile stuff because there's like an applications team that works on that. A lot of there is a bias in what platforms Tor is available for, and a lot of that has to do with what volunteers we have who can spend the time into, writing stuff to make it work on those platforms. The applications team has been working really hard recently to make the Android application much better. So I think that's been really good. And also the people at Guardian Project have been doing a lot of work on making generally anti-censorship tools available on Android. So in terms of why different things come last, yeah, I think it's an unfortunate situation, and I think that one thing that could help that is still a really hard problem is to lower the barrier to participating in these things and lower the barrier to volunteering. So choosing languages that are safe and easier to write in, and making our discussions and everything public and easily accessible. But yeah, thanks for that.
Yeah, final question, if that's all right with you.
Yeah.
Thanks. This is wonderful. I guess I'm just wondering, not about the technology, but about the Tor's approach to presenting this, and I like the watercolor that was done. And I'm just curious: is there efforts to make those sort of like work with artists to have things kind of rendered in different sorts of ways, and is that like an explicit thing or just something someone put together? And also, was not to like aha this or gotcha or anything, but like was this person paid? Like a developer would be to do some work for the project? I'm just curious, about how that's shared.
So this image was made by David Fifield, who has been volunteering for Tor Project for a very long time, and working as a graduate student and also now with funding. He was like one of the original designers and developers of Snowflake itself. And this is actually an image from his PhD thesis, which is super good, and you should read it if you're interested in this further. But yeah, thanks. These I just drew on a notepad.
Oh, yeah. It was mostly the colorful
These
ones.
are much less, lower quality than this one.
I like it.
Thanks. I do really quickly, before we wrap up, just want to mention that there is a lot of really great volunteer work. So people who are not paid by Tor Project, who have put a lot of work into Tor and all of the anti-censorship things. And so I just wanted to give a shout out to them. Another thing is the WebRTC library we are using is called Pi on WebRTC, which is a really cool project where they took the Google's Chromium WebRTC kind of specification and made it entirely in Go. So that's very cool, and it's enabled us to actually compile this for Windows and increase the number of platforms this is available on. So I wanted to give a brief shout out. And yeah, thank you.
Thank you, Cecylia. And also I love this call to read more PhD dissertations. Just before we break for lunch, just to say that we have an hour now for lunch, and as a reminder, when we come back at 2, we're going to have a slight rejig. So there's going to be a workshop still in the back Gamma space room. There's going to be one in here, and we're going to have a smaller screening in the zine library area from one of the artists in the exhibition. And also, as getting you ready for later tonight, the screening that's out in the park is going to start at 8 p.m. And I encourage you all to check that out. We're really excited to sort of have this sort of outdoor, beautiful night looking at infrastructure movies. Okay, so now we have lunch over there. Please go eat it all so we don't have any leftovers.